Good afternoon. I'm Nick Pinhey. I'm currently on the faculty at California State University Stanislaus in Central California, and I'll be presenting today on applying industrial archaeology methods to developing a case study of the City of Whittier's sewage treatment plant. Well, as the introduction said, I am going to talk about developing a case study of the City of Whittier's sewage treatment plant using IA methods. And I once again want to say good afternoon. Thank you very much for having me today. I do appreciate the opportunity to present. So let's get started. I'll give you just a brief summary of my background. I am a retired public works director, and I am a native of Los Angeles. I worked for 5 different cities in the course of my career in California. Also served as a general manager for water and wastewater utilities, and that was really my central focus and interest is the water and wastewater utilities. I am also an academic. I'm a lecturer in the CSU, the California State University system. I received a doctorate and master's from the University of Southern California, and I actually started out as a field archaeologist in the 1970s before I made my transition over to public works. And I might note that when I did transition to public works, I was actually a wastewater treatment plant operator for a number of years. So I do have the hands-on practitioner experience. I'm also past president of the California Water Environment Association, which is really the genesis of this talk I'm about to give you today, because I'm the leader of what they call the Historians Working Group. It used to be the History Committee, and I've been doing that for about 10 years now. And we have a goal to document significant developments that occurred in the history of California's wastewater collection and treatment, particularly in the 20th century. And we want to document the people, the programs, and the infrastructure that helped advance the protection of public health and the water environment in California. Now, my research goal dovetails very nicely with my role as a CWA historian. What I'm doing is developing case studies that examine how technical innovations in wastewater treatment and centralized organizational structures, in this case regionalization, were adopted to address the challenges of rapid urbanization that occurred and rapid population growth that occurred in the 20th century in Southern California. And so what I'm looking at sort of the parallel diffusion of new technologies and then the evolution from local to regional solutions that occurred primarily in the Southern California area. This process of regionalization that I'm looking at is occurring right now in Central California, following a similar pattern. And so there are lessons that we can learn from the Southern California examples. And so with that, what is my presentation about? Well, today I'm going to be talking about how I research and document historic wastewater treatment plants in California. In this case, the City of Whittier is my example. Most of these facilities are what we call forgotten facilities because the plants no longer physically exist. And in many cases, are no longer even on the books. I've gone to city engineering departments and they have almost nothing in terms of records of some of these facilities. And what I'm doing is, as I document these facilities, the results are published in the California Water Environment Association's quarterly magazine, and then they're archived electronically. And when I do that, I get a lot of feedback from the readership, my captive audience of wastewater. We have about 7,000 members. I'll get lots of comments and I'll get questions. Like, for example, we had no idea that such and such a city or district had a wastewater treatment plant. And how do you go about finding out about these particular forgotten facilities? So what I did was in response to the comments and questions, I wrote an article explaining how I go about researching a forgotten facility. And I selected the City of Whittier for the article and for the presentation because it was a good example of a facility that was particularly difficult to document and was really, truly forgotten as one of the cases. And I do demonstrate in the article how I apply the IA research toolkit to my detective work. And there you see me, that was a poster that was done for one of my presentations on the City of Pasadena facility, the sewer sleuth. Before I discuss the application of research tools, I will give you just a little bit of background on Whittier so you know what we're talking about. Like many cities in Southern California, Whittier started out as a small agriculturally based community that incorporated at the very end of the 19th century. The population is currently around 86,000 residents, and the build-out population is projected to be approximately 90 to 93,000 residents. The maps I'm showing you on the slides indicate Whittier's location in Los Angeles County. And in the one slide, you'll see the city of Whittier in red. It's approximately 17 miles southeast of downtown Los Angeles, and about 20 miles from the Pacific Ocean. The white areas on the map, the county map, are the unincorporated areas of Los Angeles County. And if you can see the little red spot that's the city of Whittier, the white area right below it is an unincorporated area, and that just happens to be where the city of Whittier sewage treatment plant was located. And this was a typical development pattern that you find in several of the small inland cities in Southern California in the late 19th and early 20th to mid 20th centuries, where they did not have the opportunity to discharge to the ocean. The pattern that you saw was they would purchase a several acres of rural land a few miles outside of the city that would be suitable for developing a sewage disposal site, preferably with the right topographic features to allow the sewage to flow by gravity. And in most cases, the site would be developed into a sewer farm where the sewage, with very minimal treatment, could be used for irrigating crops such as alfalfa or walnut orchards. So there's the little bit of background on Whittier and why Whittier. Why is this a particularly interesting case study to me, at least? Well, the city of Whittier wastewater treatment, or in this case, sewage treatment plant, I have to use the older term. It really does a good job of illustrating the impacts of growth, the adoption of new technologies, and the regionalization of wastewater treatment in Southern California. And additionally, the Whittier sewage treatment plant is closely linked to the history of the California Water Environment Association. So not only did I have a good plant for a case study, I also had a linkage to the association to make it interesting. And as an example, I found that the Whittier sewage disposal plant was a topic of many of our, in those days, the California Sewage Works Association's papers and conference presentations in a period from 1928 to 1939, and was part of a 1936 conference site tour. It was also the site for a hands-on operator symposium in 1936, and it was tied with the city of Palo Alto for the Award of Merit in 1935 for its plant. The city of Whittier's sewage disposal plant was also part of a 1948 groundwater recharge test, the spreading grounds test, where its effluent, its final effluent, was used to evaluate percolation rates for reclaimed waters to study the potential for recharging depleted groundwater in the area. Now, I've got a little chart next to the wonderful advertisement for Whittier from the early 20th century. And what I've done is I put this up because it has the growth over time per census tract over time. And it shows some particularly interesting points where you see the little red arrows, the population is jumping. That also happens to, those points also happen to coincide with the adoption and development of new technologies for treatment to try to keep up with growth in the city. And so if you look at the 1910 period, at that point, the city had just purchased some land for the sewer farm. They put in a rather large septic tank and were irrigating crops. And you see by 1920, you see a 75.8% jump in population. They had outstripped the plant's capacity and they were looking for different ways to treat. So in 1920, 21, they embarked upon an effort to actually treat the sewage using Imhoff tanks and sprinkling filters. And you see a period where they actually constructed it in 1923. Then by 1930, or actually by 1926, they were out of capacity. By 1930, not only were they out of capacity, they had to double the facility sizes, but they were also experiencing some significant problems with odors and other issues related to the plant. And anyway, all the way up to 1950, you continue to see improvements and additional expansions, additions of new technologies, trying to address the challenges that are facing the city due to population growth and actually encroaching residential development that was getting very close to the plant's boundaries. By 1950, they make a decision to actually connect to the Los Angeles County Sanitation District system. They actually regionalize at that point. I'll talk a little bit more about that in the next slides. So the city of Whittier's sewage treatment plant fit the description for, or the definition of a forgotten facility. And I determined that they had this plant. The first time I encountered it was when I was reading a history of the county sanitation districts of Los Angeles. And when I saw the mention of the city of Whittier's plant, it piqued my interest because it looked like it fit into the regionalization case studies that I was working on. But when I looked at the history of the districts, the description was very vague at best. I mean, it pretty much consisted of the city had a wastewater treatment plant or sewage treatment plant. But I really didn't know the basics of the plant. I didn't have the wheres, the whats, the whys, the when of the plant's history. And I needed to get the answers to those questions if I was going to write a case study. So how do you go about uncovering the history of a sewage treatment plant that disappeared in 1950? And when your Google searches turn up almost nothing, and nobody remembers the plant. Fortunately, we do have a structured approach that can help. And in this case, I turned to Douglas McVarish's Field Guide for American Industrial Archaeology. And in there, I found an excellent framework and discussion for sources for documenting industrial properties. I took his list of resources, I refined it a bit, called it a tools of the trade list, and applied these tools to documenting the Whittier sewage treatment plant. Now, I've just listed the sources there down on the left side of the slide, and I will go ahead and discuss how I applied each of them to the study. I should note that that list reflects the order in which I actually used these resources to document the Whittier plant. Okay, so the first stop, and by the way, JSTOR is your friend. The first stop was to take a look at the journals and trade publications that existed that may or might have documentation of the Whittier sewage disposal plant. Subsequent reviews of the journals actually sparked my, when I had reviewed the history of the districts, then I started reviewing the journals, and those really sparked my interest in documenting the sewage treatment plant. Because as a CWA historian, I noted there were at least 8 articles published on this particular facility between 1928 and 1939. And I also found advertising by equipment manufacturers using the Whittier sewage treatment plant as a testimonial of how well their equipment was being used. And also, as I mentioned, I'm a native of Southern California who has worked in water and wastewater utilities most of my career, and I was unaware that Whittier even had a plant. Naturally, that got me interested, and I had to take a look. The journals provided me with a wealth of information on the city of Whittier sewage treatment plant. And if you can see the article I popped up there, that was the one that was the most informative. It talks about the plant being about 4 miles south of the city and on a 98-acre tract of land. It actually turns out to be a 94-acre tract of land. But these articles, as informative as they are, lacked 3 key pieces of information that I needed to really get into my case study. The precise location of the plant isn't identified. There are no photographs of the plant, though I will say the Sewage and Industrial Wastes article did have some photographs of the groundwater recharge project that I mentioned earlier. And they really lacked a lot of the specific design details for plant processes and how they developed over time. Specifically, the period between 1923 to 1930 was a gap. I didn't have that information. This particular article gave me a nice little snapshot of what was going on in 1936, but I didn't know what was going on before that. And for me, location is essential for understanding how the sewer system for the city developed and what happened to the plant. So to find the location, I next turned to map research. And here you go. The digital age has made this so much easier. The accessibility of documents is just tremendous now. And researchers now have a variety of map resources available online, as I'm sure you are all aware of. from fire insurance maps to city atlases. For me, I find that the USGS, the Geological Survey topographic maps, are the best maps for locating historic water and wastewater facilities. The USGS topo maps give you a detailed record of land use and the land area, giving both the geographic positions and elevations for natural and man-made features, as well as place names and road names. The USGS topo maps are updated periodically, and the USGS has an online historic topo map explorer that makes it easy to check land area maps through time. And for this particular case study of Whittier, they have online the topo maps for 1923, 1925, 1949, and 1951. Now, based on my journal reviews, I knew that the Whittier Sewage Disposal Works was constructed around 1923 or 1924, and it was used up until 1950 or 53 per the journal citations and the recharge percolation studies that I read or had encountered. So armed with that information, I checked the 1923 and 1925 topo maps, and I got no results. The areas south of the city were not developed, pretty much just open ag land. Next, I checked the 1949 topo map, and it indicated that a sewage disposal plant was located just north of the Imperial Highway, where you see the red arrow pointing there. North of the highway and just south of Leffingwell Road near a subdivision named Sunshine Acres. The same sewage disposal plant is also shown in the 1951 map, and the location on the map is south of the city of Whittier's corporate limits by about 4 miles. And the contour lines show the slope of the land is correct for gravity flow from the city to the plant. So the 49 and 51 USGS maps matched the journal descriptions of the city of Whittier sewage disposal plant, and I determined its precise location, which was good. This is very useful for checking any surviving infrastructure of interest. One very interesting fact did emerge while examining the 1923 to 1951 topo map series. There was virtually no residential development in the vicinity of the plant during the 1920s. The later maps show that by 1951, residential development was starting to encroach on the Whittier sewage disposal plant's northern and western and eastern boundaries. Residential development from Whittier was marching southward toward the plant. So to get a better idea of what was going on, I next went to the local newspaper archives. Unfortunately, just like the maps, digital newspaper archives are now readily available online, making research much easier than the good old days of having to extract the information from library microfilm documents. I use 3 sources for newspaper articles. I use subscription sources, primarily newspaper.com. We have available also free California digital newspaper collections through the University of California, Riverside. And finally, I use digital library collections. The example I have up here, showing an article from a 1932 edition of the Whittier News, illustrates the impacts of residential growth near the Whittier sewage disposal plant, as well as providing some very good early history of the plant going back to 1909. Shows that the city had actually purchased the land for the plant in 1909 and set up a sewer farm. The article confirms what the USGS topo maps show, and that is that residential growth was encroaching on the plant boundaries. The newspaper article also gives some background on how the odor problems from the plant impacted its residential neighbors and provides some good information on plant improvements that were implemented to control odors, specifically through chlorination and the construction of a pre-aeration chamber. This information ties directly back to my association journal articles and conference papers on odor control. Finally, the article also provides some background on the plant expansions and improvements that were made in response to population growth in the Whittier area. Plus, it gives me the name of the engineering firm that designed the improvements, Black & Veatch. Knowing that there were issues with the plant, my next step was to check into governmental archives to find out what the regulatory authorities were saying about the plant and how they responded to the issues. And here we go, permits. I find these archives are especially informative when it comes to documenting these treatment plants. The permit applications, the permits, the notices of violation, the enforcement actions are all valuable sources of information on the plant design, operations, and plant problems. And given that the Whittier sewage disposal plant was encountering issues related to growth, it made sense to check for any permits that might be on file in the archives. And I find for us the best source of government records for California wastewater treatment plants that were in operation from 1901 to 1966 are records from the State Board of Health, Bureau of Sanitary Engineering, and these are archived and can be found at the University of California Riverside's Water Resources Collection and Archives. The records are searchable through the online archive of California and are listed by agency. The slide that I've got here shows a cover of a copy of the Bureau of Sanitary Engineering's findings and opinions regarding a 1927 application by the city of Whittier to expand its sewage disposal plant. You'll recall it was designed and built in 1923, and by 1927, they'd already had to file an application to expand it. The copy was retrieved from the UCR archives, and it contains the information and details on the expansion referenced in the 1932 newspaper article in the prior slide. The report also states the sewage disposal plant was originally constructed in 1923, confirming precisely the date of construction. And it meant to me that the older design did not adequately anticipate the rapid growth that would occur between 1923 and 1926. Interestingly, for me, the report was prepared by one of our association past presidents, Ray F. Gowdy. The Bureau of Sanitary Engineering's report provided information on expanding the plant in response to population growth, but it didn't contain photographs of the Whittier sewage plant. And to obtain photos, it was necessary to use the next source in my toolkit, which is the library special collections. I love them. They are excellent sources for photos. I routinely use library special collections and archives for researching both water and wastewater history in California and for obtaining photographs of historic sites. The University of Southern California's digital library collections and the UCR special collections and the public library special collections are all excellent sources. What I'm showing you in the slide is a 1931 photograph from the Huntington Library showing the city of Whittier's sewage disposal plant, specifically showing one of the Imhoff tanks being used for training Los Angeles County health inspectors. The photo was obtained from the Huntington Library's digital collection and is a good example of the high-quality photographs that are often available through library sources. In this case, the Huntington Library was able to produce several photos of the plant from 31, which are very useful for identifying the plant's layout, plant processes, and the plant location with respect to residential development, agricultural uses in the vicinity. That particular photo is oriented looking to the west, and you can see there's nothing basically in terms of development in that particular horizon at that time. So now I had the location. I had some basic description of the changes in the treatment technologies being used at the site. I had discussions of problems related to development in terms of population growth and housing. What I needed were some more specifics on the plant's unit processes and designs, and for that I turned to textbooks and engineering studies and reports. When researching these historic wastewater treatment plants, it's common to come across references to treatment processes and technologies that are no longer commonly used. And sometimes I'll run across names for equipment that are no longer used and are unfamiliar to me. And one of my favorite examples is finding treatment plants being described as using something like the wrench whirl screens for primary treatment. I have no idea what those were until I actually was able to take a look at them in the old design texts. And that's really where the textbooks on design and operations of treatment plants become valuable for determining exactly what was going on and what the processes consisted of. So to keep up with this archaic treatment technology, if you can keep up with old technology, I collect textbooks on the design and operation of water and wastewater treatment plants. Because it's really easier for me to have the books at your fingertips, as they're not always available online or sometimes not even available in libraries. The Whittier disposal plant's use of the pre-aeration chamber for odor controls mentioned in the 1935 edition of Metcalf and Eddy's American Sewerage Practice, Volume 3, Disposal of Sewage, is shown in the slide. And those books up there are actually on my bookshelf, by the way. The textbook gives you the dimensions of the chamber. It gives you the description of the process and design and the aeration system. And the text described the aeration system that was being used as a ridge and furrow type, which was also noted in the journal articles. Most importantly, the text gave me the detail for the ridge and furrow aeration system as illustrated here, which makes it clear how the diffusers are placed into sawtooth furrows at the bottom of the chamber. So the value of the textbook, in this case the Metcalf and Eddy textbook, is that it provides me with a level of detail on the design of the pre-aeration chamber that was not found in any of the journals or newspaper discussions of the Whittier plant. This for me was a great find, but the textbook focused exclusively on the pre-aeration system for Whittier. To get more information on the rest of the treatment processes specific to the plant, it was necessary to search for engineering reports and studies on the Whittier sewage treatment plant. And fortunately, I knew the firm Black & Veatch had worked on the plant, so that made it a little easier to nail down some of these studies. As I mentioned, the engineering studies are very valuable for getting information on design and construction and describing the characteristics of the wastewater generated by the community being studied. For example, you'll get descriptions of the industries that were discharging into the sewer system. These studies also provide background on the specific challenges facing the design engineer that are posed by the communities in question. In the case of the Whittier sewage disposal plant, the major challenge was the proximity of the encroaching residential development and the plant odor issues that resulted. The themes of residential growth impacts and odor control are consistent and ongoing from the 1920s to the 1940s in the Whittier sewage treatment plant's history. I was fortunate to actually be able to obtain a copy of Black & Veatch's report prepared in 1931, and it really describes an extensive odor study that was done, and then it provides recommendations for treatment improvements that were made in the 1933 to 36 period of time. There are four pieces of very valuable information I found in the report as well. One was the odor survey map, which is shown on the slide, and it confirms the precise location of the plant's treatment processes, and the odor survey map also illustrates the parcels that had been subdivided and formed around the plant. It also shows the parcel, the 94 acres of land owned by the city of Whittier, which was very useful for documenting post-treatment plant history. The map gives a lot of detail on the proximity of the residents to plants. The report does. It shows how lots were mapped. And it links back to the association articles I mentioned before. There was actually a couple of association papers on the odor control improvements and a presentation made at a conference on that. So I was able to tie the information back to the association and also get specific information on the chlorination system and how chlorination was being applied for odor control and disinfection at the Whittier facility. Last, but certainly not least, are local government documents prepared at the city, county, or district levels. In today's world, I would look at and check local agency formation commission municipal service reviews that we have in California to get background information. I'd look at city council agendas and district board reports to get similar backgrounds on treatment plants at the local level. For yesterday's plants, I do pretty much the same thing. I examine archives of board and council reports for districts and cities, and check the old municipal journals, specific municipalities being one of the major journals I take a look at, as well as Western construction periodicals for clues about plant construction and bids, and then use this information to trace local agency reports on funding and contracts. For the Whittier case study, I was very, very fortunate to be able to obtain an original copy of a 1949 water report, reclaimed water report, that was commissioned by the Los Angeles County Board of Supervisors. And this was a planning level document. And one element of the scope of work included studying the potential for the reuse of existing municipal wastewater treatment plants to produce recycled water for recharging the groundwater in the vicinity. The report is valuable because it provides an overview of the Whittier sewage disposal plant as it was operated in 1949. It provides photographs of the plant, and more importantly, it gives an indication of the regionalization that would occur with the expansion of the county sanitation districts via the creation of a new district that included the city of Whittier. And the report also gave me some good information on the decommissioning of the plant in 1950, and it really gives us an end to the city of Whittier sewage disposal plant story and a glimpse of the future with the Whittier Narrows reclamation plant. being built in 1962. The slide shows a map from the report of the Whittier sewage disposal plant. A map from the report with the Whittier sewage disposal plant incorporated as a potential site for water reclamation. The plant is marked by the circled letter E. The study was prepared by the districts in cooperation with the county, Los Angeles County Surveyor and County Flood Control District. Really gives good information on how the plant evolved over time and the addition of the new unit processes such as trickling filters, rotary distributors, and heated anaerobic digesters. And at that time, the plant was producing what was considered to be a high quality effluent that could be actually used for irrigation, industrial cooling, or groundwater recharge through spreading basins. So by using the newspaper reports, the engineering studies, and the report on the 1949 reclamation studies, I was able to determine why the city of Whittier decided to join the county sanitation districts and abandon the local sewage treatment plant. Essentially, the city reached the critical point for decision-making around 1948, where the city had just made plant improvements in 1945 and 46, and by 1948, the plant was once again near capacity. The city was, once again, receiving numerous complaints regarding odors, and even though investigations by the State Bureau of Sanitary Engineering determined that the odors were likely coming from the Wilshire Oil Company petroleum refinery just south of the plant, and many of the complaints were coming from disgruntled property owners with cesspools who could not connect to the plant. The city council, even though they determined that, the city council was still faced with a petition from nearby residents regarding the plant. Combination of the expensive ongoing improvements, expansions, coupled with headaches created by continual complaints, residential development on the plant boundaries, and restriction on plant expansions, and limits on crops that could be irrigated, led the city to seek a permanent solution, and regionalization offered that solution. So by joining the sanitation district, it was estimated that the city of Whittier's cost for treatment and disposal of sewage would be reduced by 50%, thanks to the ability to spread the costs across the district and avoid future capital costs. Not only that, they now had access to ocean disposal, so they really did have what they considered to be a permanent solution. So the city council and mayor backed that. They put a vote before the public, and it was overwhelmingly voted that the city join the district. And during the move into the districts, the plant was evaluated as a potential source for groundwater recharge. And actually, they determined that the effluent was of good quality and the percolations rates were adequate for recharge, but it was considered, or I should say, determined that it was more economically effective to use a more centralized approach, and thus the Whittier Narrows reclamation plant instead of the spreading grounds option with Whittier was the preferred alternative. That was not quite the end of the plant. The city of Whittier was hooked up to the district, and the plant was evaluated by the county sanitation districts of Los Angeles as a potential scalping plant where you could take off some of the flow, treat it, and supply the reclaimed water to irrigate pasture and hay crops for farmlands and cattle ranches south of the plant. And the general manager of the county district attempted to negotiate a water price with the landowners that would cover the cost of production of the irrigation water, which was needed to justify keeping the plant online. But the landowners had received the water for years at zero cost because they were downstream from the discharge, and they were unwilling to pay anything for it. So the plant was demolished. The outfall from the city to the treatment plant was purchased by the district and incorporated in the system. City sold the land off one parcel at a time, and the Whittier sewage treatment plant faded from memory at that point. And very quickly, just show you something what I consider to be interesting as a result of the study. This is an overlay of the location of the sewage, the old sewage plant, over what it looks like now in a Google aerial, and you can see the purple line indicates the boundaries of the lands that were part of the sewer farm, and the red indicates where the actual structures were. What I think is interesting, you can see there's a blue line. That's the old La Cañada Verde Creek. You can see that was actually channelized in a concrete channel by Flood Control District and U.S. Army Corps back about the time this area was subdivided. The other thing I find interesting is you also see there's an existing municipal water well down there on the left side, right adjacent to where the treatment plant was. And if we take a look at this, here's a comparison between 1951 and 2022. First thing you'll note is the intensity of development that occurred after 1951. It's solid residential north of the Imperial Highway there. The second thing is the change in the creek alignment. Once again, the creek was channelized. That was the creek that was used for discharge in the non-irrigation season by the treatment plant. But the third item of interest I find is the fact that you had a series of oil storage tanks south of the plant. It was the Wilshire Oil Company down there. They had a refinery. They also had a refinery up north of there. That whole area was basically oil sumps and oil tanks. And if you look at the 2022 map, you'll see now that it's been produced by or been replaced by distribution, warehousing, and commercial businesses. It really piques my interest because I wonder what the level of oil contamination is in that area in the soils, having worked in similar areas where you actually have it come bubbling up in the parking lots. Anyway, it's interesting, and there's a municipal drinking water well just north of there, which I'm sure is deep enough and sealed enough to avoid any petroleum contamination. Well, I started my inquiry by asking the what, the where, the whens, the hows, and thanks to using the IA toolkit, not only was I able to answer all the key questions, I was also able to compile enough information to prepare a comprehensive case study. And that is where I'm going to stop.